sure that our compass length was set for more than half. And we made an arc both above and below the line. Without changing the setting, we went over to the other side and we did the same thing. We made a mark both above and below. And then what did we do? We drew the line in. And when we drew this line in, it was a perpendicular bisector, so it made a 90-degree angle, and it made it so that AC and CB were the same length. Okay? Now, the theorem that we're going to look at today is on a perpendicular bisector. And it says if a point is on the perpendicular bisector of a segment, then it's equal distance from the endpoints of this segment. So I'm going to go back and take a look at this picture. If I put a point on this line anywhere, what this theorem says is if I draw a line in from A to this point, and I'm going to call it D, and I draw a line in from B to D, that these two, in fact, AD and DB, oops, go back, will be the same. Does anybody know why they would be the same? It's a theorem, so we should be able to figure out why this works. I know that all right angles are congruent, so I do know that these two angles are congruent, right? What else would I know? I know that CD is congruent to itself. How are the two triangles congruent then? Side, angle, sides. Everybody see it? So what can you tell me about this part and this part? They're congruent by CP/CTC. So the reason that this theorem works, which I've given you, is because the two triangles that get created when you draw this in, these two triangles would in fact be congruent. The converse is also true. If these two pieces are congruent, then when I draw a line in that's perpendicular through P, it will in fact be the perpendicular bisector. It will cut it into two equal parts. So let's look at an example. What is BD in this picture? It is a perpendicular bisector. I know it's a perpendicular bisector because it makes a 90-degree angle, and the segment that it intersects, it cut it into two congruent parts. So that tells me that whatever BA is and whatever BC is, they're what? They're congruent, or their measurements are equal. So what am I going to do with the values that are here? Set them equal to each other. So 4x must be equal to 6x minus 10. Normally I like to take x to where x is the largest, but this x is kind of by itself here. So I'm going to subtract 6x from both sides. I have a negative 2x is equal to a negative 10. And I'm going to divide both sides by a negative 2, and x is going to be equal to 5. Is everybody okay with this first example? Questions? What is SQ? It's also a perpendicular bisector. Again, I know it's a perpendicular bisector because it makes a 90-degree angle and it cut this segment into two congruent parts. What does that tell me about PQ and QR? They're congruent, or their measurements are equal. I didn't hear the question. I would have written it down. What would I do with these two pieces? I'm going to set them equal to each other. I'm going to put ends together by getting them on the same side. So I'm going to subtract 3n from both sides. I'm going to add 7. I have 6 equals 2n, and I'm going to divide both sides by 2, and I'm going to get n equals 3. Is n equal 3 my final answer? Why not? You're right, but why not? They asked me to find what? QR. QR is 5n minus 7, and I'm going to replace n with 3. So I have 5 times 3, which is 15 minus 7. So QR is equal to 8. Questions on this problem? The next set of theorems deals with an angle bisector. And again, we did angle bisectors with constructions. And again, I just kind of want to refresh our memories on what an angle bisector is. When we were doing the construction, we set our point on the vertex. We drew an arc. We picked up our compass. We set it on the point where the arc intersected. And we did the same thing on the other side. And then we simply connected the vertex of the angle through that point of intersection. And because it created an angle bisector, this angle and this angle, whatever they were congruent. It cut it into two equal pieces. Now, the theorem says if a point is on the angle bisector of an angle, then the point is equal distance from the sides of the angle. So I'm going to pick a point. That's here. To measure the distance from here to here, I have to make it so that this would be a right angle. It's going to be the shortest way to get from this point to this segment. Likewise, I'd do the same thing over here. And what it says is these two segments, if I label this B and I label this C, the theorem is telling me that AB is going to be the same as AC. Does anybody know why these two segments would be forced then to be the same? Well, I know that this segment is congruent to itself. I have this angle, but I also have this angle. So I have an angle, and a side. So the two triangles, in fact, are going to be congruent, which means that their corresponding parts are also going to be congruent. The theorem is giving us a shortcut, so we don't have to do that. It says if you know it's an angle bisector, then the distance from A to B and A to C is in fact going to be the same. And the converse of that is also true. It says if S to P and S to R is the same, that when I draw in from the vertex through S, it will, in fact, bisect that angle, cut it into two equal parts. So the example. What is ray NR in this picture? It's an angle bisector. I know it's an angle bisector because I can see that it cut that angle into two congruent pieces. Which means any point on the angle bisector, point R, has to be the same distance from the sides of the angles. So what can you tell me about MR and RP? They're congruent, or their measurements are equal. What am I going to do with these two values then again? I'm going to set them equal to each other. Putting my x's together, I'm going to subtract 2x from both sides. I now have 5x equals 25. And I'm going to divide both sides by 5. And I get x is equal to 5. Would this be my final answer? No. What did they ask me to find? MR. MR is equal to 7x. What am I going to replace x with? So MR is equal to 7 times 5, or MR is equal to 35. Do we have any questions?